All righty. So thanks everybody again for showing up tonight. Um, Wish this would be in person, as we were just chatting about before this started, with conferences and user groups and everything. This is a year of somewhat of a transition from virtual back to what I hope is in real life, though I think the virtual component's going to be there for, I'd say, a long time. And the ability to have a an event being streamed is advantageous for some people. So, I think it's going to be a whole new world. But I, as a speaker, would love to be standing in front of all of you tonight and actually doing this talk. But, hopefully we're getting near the end of that. So, in any event, my name is Jason Bock, and I'm a developer advocate at Rocket Mortgage. And my talk tonight is called Using Source Generators for Fun and Maybe Profit. So that's a little bit of information you can find out about me if you are so interested. If you have questions during the talk, I've got my other monitor over here, and I'll be occasionally checking the chat. If anything comes up, please feel free to put something in the chat or just come off of mute and say, hey, Jason, just like we would if we were in a room together, and, just raise your hand and get my attention. I'd love to get that interaction and try to answer your questions as best as I can. If something comes up later, feel free to email me at jason.r.bock@outlook.com. So here's a whole bunch of links to things that you may be interested. The first four links are to repositories that I have written and that I'm going to be showing in my demos tonight. Okay. So feel free to take a look at them later, or take a look at them now as I go through the demos and follow along if you'd like. That's totally up to you. That last link in the bottom is where you can find presentations that I've done in the past, including this one. So go ahead and download that if you'd like. There's notes in every slide, and sometimes I have links to things that I'm showing in the slide. So that may be helpful. The last slide, in that notes section, I have links to a whole bunch of things, to references. So that's a place for you to go and dive deeper if you want to. So I'm going to spend a little bit of time on the what and the why, and why, what these are and why I think they're so important, and why I think this is such a cool feature that you should be taking a look at. The majority of the talk is going to be in demos and showing how these things work and what they do. And then we have a little bit of a call to action at the end as a motivation to where do you go from here after you've seen all this material. All right, so let's start with the what and the why. First of all, what? What are source generators? What is this new feature that's in C#9? And to be clear, this is a C#9 feature. So if you're writing an application or maintaining something that is in C#7, C#6, this is unfortunately something that you can't use, because as you're going to see, this required a change to the compiler, and that change was done in .NET 5. So this only works from that version and beyond. Okay. But what is a source generator? What exactly is going on here? You can think of a source generator as a factory. If you've ever been in a factory, and I've been in a couple myself, when I was in college, sometimes over the summers, I'd actually work in a factory to make some money. And it wasn't the most pleasant work, but it was kind of interesting to see how things actually happened. You get all this material to start with, whether it's raw material that you're putting in a die-cast machine to fabricate the parts, or you get the parts from some other supplier. There's going to be probably a handful of all these cases. And as you go down the assembly line, more and more of these things are put together to where you get to the end where you have the finished product, in this case, a car. Okay. You can think of source generators as essentially being the same thing. You have this raw material, which is typically code, and you're going to be looking at this code and making determinations as to what you want to build from looking at that source code and producing something on the other side. Okay. So one thing to notice here is you are building new code. And I use the word new in a way to say you are not modifying currently existing code. Okay. So if you've ever worked in a programming language that allowed you to do code modification or had a very rich meta programming model, this doesn't quite get there. So you can't take code that you currently have and change all of it around and have something come out the other end that's completely different than what the user typed in. You can sort of fake this with partials, and we'll talk about that later on. But at the end of the day, you're still only creating new things. But don't take that as a limitation. That's actually still a very powerful feature. Okay. And you're not just limited to looking at currently existing C# code. As you'll see in the demo, a generator essentially implements one interface and has an attribute declared on the class. And this is all the things that you need for the compiler to hook everything up and tell you information about code that's there so they can produce new code. But while you're in that generator, you could pretty much do whatever you want. There's a way for you to specify in a CS project file additional files. And so you can look at those in your source generator. They could be JSON files, XML files, things like that. Read their contents and make determinations as to what you want to build from what you see in those additional files. You could, if you wanted to, go off to a database or service or whatever you want to read some information, and that would influence the source generation process. Thing to keep in mind, though, is that this is part of the compiler. So you are hooking into the compilations pipeline. Moreover, that when you're using a source generator within something like Visual Studio or Rider or any other IDEs, you're going to see that your generator is run not just at compile time, but when changes occur. And when those changes occur, that is a little nebulous. It's kind of just whenever Visual Studio decides to run yours, but you'll definitely see that it's not just at compile time. So you want to make sure that your generator is working really, really fast as you can make it, because you don't want to give the user a bad experience. They're typing something in, your generator kicks in, and yeah, Visual Studio may run that in the background or something like that, but that may be taking up a fair amount of resources. So just be cognizant of that. But you don't have to look at just code. You can look at a whole bunch of different inputs to make your determination as to what you write on the other side. Okay. And again, we'll go through demos so you can see how this all works. But why? Why is this actually such a cool thing? I mean, I've now written 4 source generators that I have in GitHub repositories, and I've been doing this talk at a number of conferences and user groups and hope to continue doing it throughout this year. I'm really, really excited about this feature. Why? What makes this such an appealing thing? I think there's 2 reasons. One of them has to do with speed. We all want to write fast code. We all want to write code that as soon as the user does something in our applications, things just happen. They get results back really quick. The feedback is instantaneous, as fast as we can make it, and our users are happy. So we want things to be fast. If you've ever used something like reflection or expression trees or reflection.emit, these tools, these libraries that allow you to do introspection on your code, dynamic invocations of methods, creating whole new code through an expression tree. These are really powerful tools, but they come at a cost. Reflection isn't cheap, and I'm not going to specify how expensive, because that is something that you really want to measure on your machine and in the hosts and the environments that you're going to be running in. There's no hard and fast number here, but you will probably see performance being eaten up in those areas. And maybe it's just something that you do once and you're done and you never really touch that code at all. So it's something that the user would never see. But it is something you have to be aware of, that power comes at on a balance of a scale. That power comes with potentially some speed concerns. Okay. With source generators, you can take a path that you've written in reflection and write out that path that your code needs to do directly in C#. And so it's going to be compiled into your assembly and run just as fast as any other C# code would. This has the potential of making your application run much faster in these cases. And for some libraries that are highly dependent upon reflection, I'll talk about one later on, you can get those performance increases. You can potentially get those performance increases by using source generators. Not a guarantee, but it's one thing that you could definitely use source generators for. Another one is that elimination of those kind of, ironically, I talked about an assembly line in a factory, but that's rote work. That's stuff that you just do over and over and over again. And it is necessary in some ways. We all need clothing. We all need to have, things being manufactured. But that stuff is things that if we think about what we do in development, we could think of a lot of things that are like this, but they're not fun. They're not interesting. They're essentially almost solve problems if you want to think of it that way. So if we could make that something that is just done for us, we can go off and start solving more interesting problems and make that something that is always going to be generated in the best possible way. Okay. So let me show you a couple of just code examples real quick before we get in the demos to illustrate these 2 points. If I was in the room right now, I'd ask all of you, how many of you have used iNotify property change? And I would bet that there's going to be at least some people that are going to raise their hand, maybe put in the chat and say, I have, or something like that. Okay. I would imagine there's got to be some people that have used this. And if you don't know what iNotify property change is, it's kind of the de facto standard interface to say, I have a property that's changed its value in my object. Okay. So to do that, for example, in this code, we have a customer and they have a property name that when you set that property, you check to see if it's different than what you currently have, if the value given is different. You'll set your internal backing field to that new value, and then you'll call something like notify property change. Now, how you implement this can vary. There are a couple different ways to do it, but essentially you need to have an event called property change that you're going to invoke whenever a property changes. Okay. So you'll see in this case, we can use this little trick with caller member name attribute, because that will pick up who called me, in this case, the property name. So that will automatically be filled in for us. We can use that little Elvis operator, the question mark dot, to make sure that our event is actually good, somebody subscribed to, and we can call invoke on it. Okay. None of this is hard. None of the, and okay, maybe if you're new to C#, understandable, this might be something you're not used to. But in the grand scheme of things, of all the stuff you can do in the C programming language, this is relatively straightforward. But it's boring. Okay, this is not something that people want to, ascribe to say, I'm the master of iNotify property change. This is repetitive. This is rote. We know we need to do this every single time. So how could we do this with a source generator? In fact, what's interesting is the Microsoft team, and the C# team in specific, said that this was their canonical example, or at least it was one of them. If they couldn't have a way to solve this through a source generator, they failed. They have to make this work. And so you'll see in the links I have in the last slide, if you go to their source generator cookbook and their examples, they have a way to do this, and it looks like this. Okay, so now just think again, we went from all this code to this. And so what is this doing? Well, you'll notice, first of all, it's a partial. Remember way back in C# 1.0 days, there was this partial thing. And truth be told, I never defined anything as a partial. It just never came up. In part because a lot of people weren't doing code generation. That's essentially what partial was there for. It solved a problem with WinForms. Okay. And what partial does is it just says, I can have multiple definitions of this type in my project. And at compile time, the compiler is just going to mash all of them together and come up with one definition. Okay. So in this case, here's my customer definition where I have one private field that I put an attribute on called auto notify. And what this example from Microsoft does is they create in a source generator another partial class called customer, where they do all of the stuff that you just saw here, except you don't have to write that. They'll generate all the code for the setter and the invocation of the event. All that stuff is done. So then all you need to do, just declare field, declare property on it, and you can move on. It's a lot less code for you to write. Okay. The other thing I mentioned is speed. So consider the example of I want to take a source object and I want to map it to a destination object. And there are libraries to do this, like AutoMapper. If you go to NuGet, I think the last time I checked, it had like over 100 million downloads. It's a very popular library. And I want to be very clear, even though I talk about it, I am not picking on it, even though I'm going to use it in some examples. The reason that I use it is because it's actually a library that's gone through a lot of care and effort to make it as fast as it possibly can. Okay. You say, I've got a source, I got a destination, and it's going to figure out how to map them. And I'm not saying this is the code. In fact, this is code that I just wrote to say, if I needed to do something like that, and this is a fairly simplistic implementation, I would use reflection to find the getters and the setters, and do they have the right visibility, and are they instance properties, and do they have the same types? And if so, then I would set one value to the other. Okay. So this would work, but when you're using reflection, you're going to get some kind of hit. And I'll show you some benchmark.net tests in a little later on. Okay. What if I could do this? So if I have a type called source and I have a type called destination, and I know there's 5 properties that match between them, why can't I have a source generator do something like this that gives me the fastest possible path for object mapping? Maybe there's actually even a quicker way. Maybe you want to do some little tricks with, memory management or pointers or something like that. That's possible. Then you could write a generator to do that. But the point is that this is code that's wired to do exactly what you would want to do with an object mapper in C# code. And the end result of this is you get code that's faster. Okay. So to do this with source generators, you have to spend a little bit of time doing some research, because this is based on compiler stuff. In fact, if you've ever heard of Project Roslyn, the compiler API, this is right in that wheelhouse. Okay, so if you've done things like building analyzers, refactorings, things like that, code fixes, this should be fairly a good thing to jump into, because you already know a lot of the concepts. If you haven't, it's just, there is a little bit of a learning curve. You have to get used to syntax trees and semantic models and stuff like that. I don't want to make it sound like it's an impossible task, because that's not the case at all. Just be aware that in like the 5 or 6 years I have been using now the compiler API since it's been released in 2015, writing analyzers and code fixes and all this stuff, there's always cases that I find that I just didn't realize, because people write C# code in a different way, or I didn't realize that you could do something like what is possible in C#. It's just, you never really see people doing it that way. Okay. So you have to be cognizant of that. You have to be aware of that. But this is where the profit part comes in, because if you spend that time doing that research, working on building source generators, and maybe you're going to stumble a bit, maybe things are not going to work the way you want them to. But if you think about, this is what I want to do in my source generator, this is the end result of what I want. And so what do I need to look at, and what kind of code would I want to generate? You're probably going to get to a point where you can say, hey, I now have this source generator that does all this stuff for me, and I don't have to do it anymore. And so now you're going to save time. Time is money. People like to hear that you're saving time, because you're saving money, and you can go off and work on more interesting things. And maybe that stuff gets to a point where you could source generate that as well. Maybe, maybe not, but there is a benefit here in a couple of different ways. So let me go through some demos here and talk about how you can use source generators. So let me go over here and go back to Zoom, which for some reason on my other screen over here, it's being a little difficult. doesn't want to show me the full view here. I don't know what I'm doing wrong on on Zoom. This is a new one. I just wanted to see if there was anything in the chat or any questions. So hey, that's not what I wanted. Sorry about this. I've never had Zoom do this where the view is not quite what I want it to be. Hold on, just give me one more minute here. I'm going to pull this over here. It might be because of the screen I'm on and it's just being a little. Oh, there we go. Chat, that's what I wanted to see. Okay, thank you. Thank you. Okay, so I said EF has partials by default. Yeah, that's true. And there are some other libraries that would build things as partials. But the nice thing about partials is that it works really, really well with source generators. So if other libraries had decided to already use them for whatever reasons that they might have been generating code along with it, or allow people to extend the stuff that they're creating with their own definitions, that's fine. So, all right, get this back over here. And let me go into my first demo. And I want to get rid of this thing at the top now. Go away. Go away. Do you remember what you have to do to get this to hide floating media control? Thank you. Okay. That's not what I wanted. That's all right. Come on. You go over there. There you go. Perfect. Now you're not in my way. Okay. So actually what I want to do here is open up a project called Source Generator Demos. Okay. And so this Source Generator Demos project uses the NuGet packages that are already out there in NuGet that I've created. And then I'll dive into each repository individually to show you what the code looks like. Okay. So let me get these out of the way here. And the first thing we're going to do is look at an object mapper. Okay. Demo inline mapping. Okay. So in this code, you can see that I have a source object. I have 12 into it. You can see that it has an ID. And by the way, did you just notice all those code lens reference errors pop up in Visual Studio? That's actually a bug that I found and other people have found that only pops up when you're actually doing source code generation. For some reason, CodeLens throws fits with the actual code that's generated and has nothing to do with what you generated. It just doesn't like you doing that. And so you see, so you just have to ignore all those yellow things at the top. I think they're going to fix it in 16.10. I'm not sure, but hopefully they fix it soon because it's a little painful to see. But anyway, everything will work. You just have to ignore it. All right. So we have a source definition. We have another destination definition. And you'll notice that on the source, we have a map to destination. So this is an attribute in my inline mapping package that says, if you put it on a type, it will say, I can actually map to this destination type. Okay. And the names don't matter. I'm just literally using source and destination to make it clear. So you can see where we have an ID, a name, and a when of a date time. Those three match over here, but reason doesn't. There's no property to match on that. Okay. So if I come back up to demo inline mapping, you'll see that I'm creating a new source. I'll print out its values here. I'm then calling this map to destination method, which you didn't see that on source. So it's kind of a little weird at first. Where did that come from? But that produces on the other side of the return value a destination. And that destination, we're going to print out all of its values as well. So if I run this, what we should see is the ID, name, and when being the exact same on both sides. The reason shouldn't be set though, because we couldn't find a match. And as you'll see here, that's why we have the comma with nothing at the end, because that string is empty or it's null. Okay. All right. So what did map to destination do? This is where I'm going to open up another instance of Visual Studio and we'll go to this project. So this one I'm going to go through in a little bit of detail because I want you to see the mechanisms and the mechanics behind a source generator. The other two, you'll just kind of see how they work and get a feel for what's being done in there. Those two examples, especially the last one, is quite complicated. So I don't want to go through all the gyrations there, but you're going to see kind of the end result and hopefully some of the power that you get from source generators. So this first one, inline mapping, I want to show you in the CS project what you should be aware of. The first thing is you want to make sure that your target framework is .NET Standard 2.0. That is a requirement. Okay, so you just have to use that in your project if you want to have a source generator. Okay, and you can have other, you can see have a whole bunch of other properties here, but we're not going to cover those. We just want to make sure that you understand target framework, .NET Standard 2.0, and then the package references here, that they're these two code analysis analyzers and C# packages. If you have the analyzer, okay, I'm sorry, not an analyzer, source generator. Okay, so you've got a project set up and you want to build this source generator that's going to look at two objects and determine what's exactly the same between them. So the first thing we're going to look at here is the actual map generator. Okay. And as I said before, there's an interface that you have to implement, iSource generator, and this in place, you're good. Of course, now you have to implement the interface. There's two methods that you have to implement, execute and initialize. And execute is the one that's really where everything starts, okay? You may not do anything with an initialize. And in fact, you're not required to do so. You can just make that a no-op if you want. But the one thing to keep in mind here is with source generators and initialize is that you maybe it's right off the bat and say, I know that this is something I'm looking for. In my case, I want to find where classes have a map to attribute. I also have a map from attribute, which goes the other way. And then I have a map attribute that you can declare at the assembly level and say, I can map from this to this. Yeah. So what I want to do is find cases in the syntax trees. And those are trees that represent all the source code in your project. I want to find cases where that attribute comes up. Okay. And so what I'm going to do here is I'm going to register for syntax notifications. And this, you just pass in this action essentially to say, I'm sorry, not an action, it's a func, where I basically say, I'm going to return this new map receiver. Okay. What does a map receiver look like? It just implements this iSyntax context receiver. You can do an iSyntax receiver or an iSyntax context receiver. The difference between the two is you're going to get a different context given or a different object given to you when you visit the syntax node. Okay. The differences between the two are a little subtle, but at the end of the day, what you're going to get is information about the trees that are in your code as they are visited. That's why they use the word on visit here. There's actually a visitor pattern going on underneath the scenes. And so you want to find the nodes that you're actually looking for. Okay, I keep talking about syntax trees and nodes and semantic models and blah, blah, blah. And you might be going, what actually is all this? Okay. Let me go back to the example over here in Source Generators demo. Let me go back down to this definition. So when I talked about the path that you need to go down, the path I need to go down is, in the case of map 2, I need to look at what type it's defined on, and then what is the type that's passed into that attribute. Now, if you don't know anything about the compiler API, you may go, I have no idea where to start. And that's totally fair. If you use Visual Studio, there is an SDK that you can install called the Compiler API SDK. It's in the installer. If you haven't done that yet, install it. In fact, you probably, in some cases, almost need that for some of the things you're doing in the compiler API. But the one thing that you get out of that is the syntax visualizer window, okay? So that window, and I'm going to pin it here. If I click on my code here, you notice that what I get over on the syntax tree is that whole syntax tree representation of this code here. It always starts with the compilation unit. And then you can see we've got using directives here. Then we got global statements because we're using top level statements. That's a new C# 9 feature. Well, if I go back to this code here, you'll notice that the tree is highlighted on trivia. Its parent is the closed bracket trivia. Its parent is an attribute list, and its parent is a class declaration. Okay. So the point of this tool is that you could just type in C# code that you think you're going to be looking for, and then use a syntax visualizer to say, oh, that's what I'm actually going to be looking for. That's the thing I'm going to try to find in my source generator. Okay. So if you come back here and I go to my map receiver, what you're going to be noticing is I'm actually looking for type declaration syntax. Okay. And the reason why is because, again, a class declaration actually derives from a type declaration, because you can have classes or you can have structs. And in the compiler API, they both derive from a type declaration. Okay. But you can see that here, class declaration syntax. So that's that hint to tell you that that's the thing that you want to start looking for. Okay. And in my case, I want to find a type declaration syntax that, again, if you squint at this code hard enough, you're going to start to see things like I'm looking for.
Jason, this is Nick Olson in the Twin Cities, actually. I was just going to say, if you had time, you were talking about performance, and if you could go over like the relative difference between like the semantic model versus like syntax trees, if there is a difference there.
I will try to answer that when I get to, I'm going to talk a little bit about performance here. So we can discuss that at that point. So by the way, hi, Nick, I know who you are.
Yes.
All right. So I think I stopped and I got cut off where I was talking about starting to generate code. At the end of the day, it doesn't matter how you do it. You just want to get to the point where you are creating C# code in a string. Technically, it's source text, but however you create that string of C# code, that's up to you. I'm actually just going to be using an indented text writer from, of all things, the CodeNom API. Okay, because then I can actually indent and outdent and produce code that looks kind of nice. There's a NuGet package called Scribian, which is kind of a templating engine in a NuGet package. And if you take a look at that, that might be what you want to use as well, or give that a shot. You may actually want to create syntax trees using the compiler API and do a toString on that. That's another option. There's all different ways to do it. Okay? But again, you just need that text of your C# code. So in my case, what I'm trying to do is I'm trying to find the mappings between the two properties. And so if I go to this mapping information class, actually what I do in here is I'm going to start checking to see, are there properties that have accessibility that I can see? Is there a constructor on the destination type that is visible? And if it's not, notice what I'm going to do here is I'm going to add to this diagnostics array another diagnostic. That ends up showing up as an error in your output. And so you can make diagnostics that end up in your error list and say to the compiler, hey, something bad happened here, or inform the user, I can't create an instance of the destination, so I can't map to something that I can't create. Okay. And there are other things I'm going to be adding, like there's no match. Like I might find a property that I don't have a match between the two. So I might just say, I'll create a diagnostic that may be not an error, but just tell the user, hey, I couldn't find a map between these two, just to let you know. And that's what this code is doing here. I am doing a little bit of hand waving here because I don't want to go through every single line of code, but just to get, give you that feel of what I'm doing here, where I'm going through all the destination properties, checking their accessibility, seeing if there's a match on the source properties. And if there is, then at some point here, these property maps, I'm going to say, you can start to see C# code here, where I'm taking that destination properties name, saying it's equal to what I'm going to get passed into me in an extension method, which I call self dot the source property name, and then a comma. And I'm going to start to just build up a list of these things. Okay. So if I go back to my map generator here, the builder is where I'm actually going to be generating all the code. Okay. So you can see here, this is where that indented text writer comes into play. And you can actually look to see if a user prefers tabs or spaces or something like that. So I'm trying to honor that here as well. And here's some more C# code where I'm going to put in the right using statements. and may need it for the destination type as well. Okay. Here's where I'm going to start to generate that static class. I'm going to put that extension method in. Here's that map to destination. Here's that extension method you saw before. Okay. With the first property being called self. That's from my small talk days when I never wrote small talk, but that's where I grabbed that from. I also put a check in here because if what's being given to me is not a value type, I want to make sure that it is a null. And so I'll write that code in there. Again, you've got all the power to do whatever you want. So you can put all these things in here as you need them. And then I finally get to where I'm going to be making a new instance of the destination type. I'm going to put all those maps or those property setters and what you saw before, they're just going to be written out one by one. And then I eventually close off that method and that class definition, and I'm done. And I return all that text as a source text. Okay. So just to reiterate, in the generator, I have a receiver that finds all the candidates and all the cases that I'm looking for. In the execute here, I'll go through and find any potentially errors and create diagnostics if I need to through my mapping information. And then in my builder here is where I'm actually generating the code. I want to be clear, you don't have to follow this. You don't have to create information classes or builder classes. That's just what I do. I just find this nice to separate out how I'm validating what I'm looking at and then how I'm building that code out gives me C# code at the end. So now if I go back to my demo here, okay, and I'll unpin this, and I'll come back up here, and I do an F12 and map to destination, that's what the generated code looks like. And just to show you that Visual Studio will run this more often than not, okay, I will come back down here and I will say, okay, let's take the reason value or the reason property and put it on source, and now it's added. Okay. So now I have that mapping just occurs because the source generator picks it up. If I go back to taking it off, it will disappear. And this code is built into your assembly. If you use a tool like ILSpy, you'll look in the assembly and you'll actually see this is just generated right within it. And so the nice thing about this compared to other tools, like if you've done IL weaving tools or stuff like that, because this is direct C# code, I can put a breakpoint here. And let's make sure I'm in debug mode, which I am. So let's launch this in the debugger. And once Visual Studio takes its sweet, sweet time. Come on, you can do it. See, this is a good time for a beer. So, there we go. All right, finally there. Okay, so I'm on this line, and if I F11, it goes right into the generated code. Okay. And I can just hover over self and I can see it's a source and I can see its property values and everything's good. Okay. So these are debuggable. Now you as a consumer of the source generator, you probably don't know or care that you can do this. This is just code that's there to solve a problem for you. But as an author, this is so nice because I use all the stuff, all the tools that are in Visual Studio, all the debugger capabilities. And if I did something wrong and I screwed something up, I can see it right away. In fact, if I mess up the source code generation, the C# compiler is just going to tell me I wrote invalid C# code. And so I can go, oh, that's nice. So cool. Then I can just fix it that way. I want to talk a little bit about performance as well in this case with the source generator. So if I go back to the Inline Mapping project, so I'm going to first talk about performance from the standpoint of comparing a couple of different ways of doing this. So I mentioned in this case, I mentioned about, performance in terms of reflection and using it with Object Mapper or things like that. So I wrote a little console tool using benchmark.net to compare mappings using my map to destination, my source generator, using a reflection approach, and then I actually use AutoMapper. Okay. I'm not going to run this here because that would take some time. But at the end of the day, when I compared these three, and to be clear, when you do a benchmark, you always have to take it in context. So don't look at this as that I'm trying to harp on AutoMapper in any way, shape, or form. But what I found interesting is when I looked at the results is The inline way is an order of magnitude faster than AutoMapper. And it's 3 times as fast as my somewhat dubious reflection implementation that I did. Furthermore, the memory allocation is the smallest between all 3. Okay. Now, the thing to keep in mind with AutoMapper is, as far as I know, it hasn't been done, it hasn't had any updates with .NET 5, with C# 9 and using source generators. It's possible that that library could as well be optimized to use source generators, and then it might hit these numbers or even go lower. I don't know. It's possible. But this is, to me, one of those clear indicators of where the performance gains are with source generators. Now, the question that Nick asked is, what's like, and if I phrase this wrong, let me know, but like, what's the difference of performance between semantic and syntax? I personally don't know. I've never done any analysis between the two. But, so honestly, I'm not even going to try to come up with an answer because I don't want to give you anything that's incorrect. One could imagine that if you use just syntax stuff, that you may be faster because you're never trying to invoke the semantic model, and maybe trying to get, the cost of getting more information, maybe that it runs a little bit slower. But at the same time, with a syntax tree, unless you have a very clear path to what you're looking at in your code, it can get to be really hard. Like that attribute stuff I showed you before, at least from what I found, trying to do that with the syntax tree can get to be really, really hard, because you don't know if that attribute that you find is actually the attribute you defined in the library. Just because it would have the same name as map to attribute doesn't mean it's the actual map to attribute that I have defined in my inline mapping project. Whereas a semantic model gives you that semantic information to say, yeah, those are exactly the same, or no, those are 2 different attributes. Okay. So if I can, I typically just go to the semantic model because it makes my life easier. And I haven't seen anything with performance, but again, I haven't done that kind of hardcore analysis to see which one's better or not. So it's kind of an interesting question, but I'll leave that to the compiler API team to answer. Okay, these other 2 examples, I just kind of want to show you a little bit of how, like what they're doing, and not necessarily get into the code, because like I said, they're quite involved, but you can take a look at the repositories later on if you want. So this next one is called partially applied, and this is with my partially applied library. So there's this concept in programming languages where you can have partial function application. And the really short definition I'm going to give tonight is, if you have a method that takes 3 parameters or 3 arguments, if I want to always have the first argument be this value, whatever that value is, I never want to change it. What you can do in some languages like Python, there's another language I found called Pony that's really interesting, and they have this capability as well. I think F# does as well. But you can basically say, I want to create a new function based off a function that always takes that always has that first value equal to whatever you want it to be. Okay. So you no longer have to keep passing that first value in. This has been sort of done in C# before, in that you can use funcs and actions to do that. But while in most cases, you can create all these different extension methods for all up to 16 or 17 possibilities. And quite frankly, if you have a method that has more than 16 arguments, you have more than 16 problems on your hand. So, but if you do have a method that has like 30 parameters, a func or an action you can't use that in that case. If you have optional values, you can't use an action or a func either. So I thought, could I use a generator to give me what I want for partial function application? As it turns out, you can. And you can also support those edge cases if you want. So for example, if I have a maths.add, which I said maths, I do the British way of it. And I actually did this talk for .NET Oxford like a month or 2 ago, so they appreciated that. But I wanted to separate it from system.math. but I just have a add method, and then I also have an add optionals. And notice that in this case, all those values are optional. Okay. And then I also have a functions that takes a multiply that so happens to have the same signature as an add. They take two ints and they return an int. That's important. Okay. Keep that in mind. I come back up here and I say, I want to take that maths add function and I always want to pass in 3. Okay. So I'm going to have a function here that will always increment a value by 3. Okay. And if I hover over it, if you squint hard enough, you can see that now I have an int, a function that takes an int and returns an int. Okay. So I'll print out what happens when I pass in 4 to that function. And then I have functions and I say I want to do a tripler, which is basically saying always multiply whatever you give me by 3. Okay. Then I also want to do this with optionals. Okay. Now notice what comes out the end here. It's a delegate. This is a delegate that I'm generating on a fly because I need to support this case where I have a function with optional values declared. So now I can call it where I don't pass anything in, or I pass in a 10, or I pass in a 10 and a 20. Now let me run this so we can see what the answers are for all of these. Yeah. And as you can see, the increment 3 plus 4 would be 7. To triple 4 would be 12. The add with 3 with no arguments is going to be 12. And why is that? 3, 4, 5. That's 7, 5, 12. Okay. But if I pass in a 10, it's going to be 18. And if I pass in a 10 and a 20, it's going to be 33. Okay. So what this source generator is doing is if I actually F12 and to apply here is a couple of things. The first thing it's doing is it's generating this apply method here. And this works for both the add and the multiply. The reason why is because their function signatures are exactly the same. They take two ints and return an int. So what those methods do, we don't care. Doesn't matter what they're doing underneath the scenes. We just take that method and then we use C#'s ability to close over a value outside the scope. And that's what we're doing here with new. We're creating a new func that takes an int and returns an int. Okay. And you're going to pass in a value, which is the second argument to that function. And that's what we pass in here. And we're just hard coding A. Whatever you gave us as A, that's what we're going to be passing in. So in one case, it works for add. In another case, it works for multiply. Okay, but it's the same apply function that we've generated here. In the case of the method that has optional arguments, I just declare delegates and I have this kind of weird auto incrementing 12 number here just to keep them different. Doesn't matter what the name is, so long as it matches correctly to what our target function was, which takes 3 values with optional 3, 4, and 5. And then we have a way to pass in one value, which we're going to capture here, and take 2 other values as well. Or we don't pass in anything at all, or just one, as you saw before. Okay, so that's how all this kind of works. So by having source generators, we're able to support some extra cases that you couldn't necessarily do with just simply functions and actions. And it doesn't matter what you give me, the generator will just react accordingly and produce the right delegates that we need. Okay. Now, the last one I want to show is called Rocks. This is a mocking library that I wrote, started about 2014, 2015. And it was kind of in response to MOQ and NSubstitute, which are great mocking libraries. And I want to be very clear, I'm not going to get into a discussion of are mocking libraries good or bad? Should you do them in tests? Should you not? We could have all sorts of arguments and discussions around that. That's not what I want to focus on tonight. What I want to get into is this library is different than MOQ or NSubstitute, in that those libraries are actually generating types on the fly using something like reflection emit or monoCecil or some other library that does IL generation. Okay. Cool stuff. Pretty hard to debug and write tests around. I've done that many, many times myself, and it can get quite squirrely to do that. Again, not impossible, but it does get a little difficult. So I said, could I just write something that generates C# code and then compiles that and builds my mocks that way? And so that was the first iteration of Rocks, which really didn't use the compiler API all that much, because I would read the contents of a type using reflection, create a bunch of C# code in a string, and then just use the compiler API to emit an assembly based on what it saw in that C# code. So the compiler API usage was minimal. When source generators came around, I completely rewrote everything, and now it's all source generator based. And it's an interesting example because now I can generate APIs on the fly that I think could arguably make it a little bit easier. Maybe not, you might disagree with the way I did this, but let me just show you what I did so you can get an idea as to what this library does, okay? So I'm gonna go down to, let's go to customer repository because that's where all the Rocks demo stuff is. So I've got a record here, okay? It takes 3 values, that's our customer repository. And some of this is a little, trivial. It's more to fit into a demo than anything, but it'll show that you'll get the point across. Can return an integer, or I'm sorry, an ID as an int. Can retrieve a customer, and it can delete that customer based on an identifier. This stuff should be very familiar if you've done DI, IOC, and you've done repositories or any type of injection of a dependency. Okay. As you can see here, we have a class retriever that takes a repository on its constructor, and then in its get method, it's going to go off and call the repository and say retrieve it based on that exact ID that's given. Okay. So if I'm going to write a test, I want to write a test that's not going to pass in the implementation of the repository that may actually be going off to a database. I want to test something that's a mock of it, set up some expectations on it, and then verify that it was called and used in the exact way that I thought it was supposed to be. Okay. So I have a customer here. That's what I'm going to return from retrieve. Then I have rock create passing in that iCustomer repository. When you use rocks and you call create this way, my source generator goes off, looks at this type, finds all the things that are accessible that are virtual, okay, and starts giving me hooks into setting up expectations for them. That's what you're seeing on these 2 lines here. But if you've ever used MOQ, and the way I used to do it in Rocks is you'd have like a setup method. And then what you're passing into that setup method is actually an expression tree that you have to parse at runtime to see what the expectation is. That's not the case here. In fact, what I do now, let's just look at the methods one here. Rock.methods. Okay. So this is an extension method that I generate from the Rocks to say, here's all the methods that you could possibly set up expectations for. And then I do a dot, and of course with IntelliSense, unfortunately, it's getting in the way a little bit here because we're showing everything that we could possibly see. Let's just go look at the extension methods, and now we just see delete and retrieve. Okay. Well, in our case, we want to say we're going to have retrieve called, and we're going to get that ID passed into retrieve. That's our expectation, and we also need to return that customer back. Okay, and we could also do call count if we wanted to. Maybe this gets called 3 times, okay? So I want to say that this should happen 3 times in the code under test. But in this case, we don't want to do that, okay? And in fact, I don't want to put this here again because I've already done this expectation, okay? Then I call rock.instance. This gives me an instance back of the mock that I'm going to use. And if I had passed in a type here that had a constructor that took arguments, there would be an instance method here, an overload of it that would also let you provide those arguments, and those would just be passed in to the mock types constructor, okay? Now I can pass that mock into the retriever. I can call get, which it in turn is going to call our retrieve and get back our customer. Now in this case, let's see what happens when we run this code. And once it does all the stuff it needs to do to finally get to the point where it's actually going to run this, we get an exception. And the reason we're getting an exception is because we have this expectation that the getter on the ID property, its getter, is going to return an ID. In other words, it's somebody's trying to retrieve the value there, but that never happens in our code path. So let me take that out. Okay. And now let's run this again. We get no errors. Now, typically you would use this in a unit test scenario. Okay. I'm just doing this at the command line, but doesn't matter. It's, it's the point of I'm able to use this mock to do verifications of what we set up in our mock class, our mock instance. And just so you can see all the things that Rock's doing, again, if I F12 onto one of these, you can, and believe me, this is stuff that you would not look at if you were using this. You're just going to let it, just kind of push away and just say, I'm just going to use this. But here's where all the methods are. They're going to be in this method expectations. Here's our properties. I can also get all the getters from our property expectations. I just generate all this so that you get this API that matches what's possible to do expectations on. In my instance, this is where I create a new instance of my mock, and that's what's defined as this private class here, okay? And you'll notice in its implementation of retrieve, I'm checking to see, was an expectation set and did I match it correctly? And then if I have to return a value, should I return that value? And then I need to increment the call count to make sure that the call count expectations were set correctly, okay? And then also throw an exception if something didn't happen what I was expecting to happen, okay? So again, all this is just done within the generator. So you can do some, what I would consider to be some pretty powerful things with source generators where you can create this a rich experience with an API, in this case with a mocking library. Yeah. I don't see any other questions, so I'm just going to continue on with the talk. And go back here, and we'll make sure that I'm showing my stuff. Okay, so that's probably a lot to take in, and there's no gentle introduction into source generators. I try to make it as gentle as I can, hopefully get you a little bit excited as to see what's possible to be done. But it is going to take a little bit of work. But that's kind of my call to action here is I want you to start thinking about things that you might be able to do with source generators. Even if what I showed you doesn't really click right now, it doesn't make any sense, that's okay. Just kind of keep that in the back of your head and start looking at your projects, assuming that you're doing them in C#9, or if you're not and you see something that you're doing that you're like, I think we could really get an advantage out of C#9 if we wrote this as a source, this part as a source generator. That may be the motivation or another motivation to move to the latest version. But start thinking about those things. Start thinking about places that you might be able to do this. And there are a lot of examples out there already on people using source generators. This is just a very brief list. There's actually a site called like Awesome Source Generators where somebody has curated a whole bunch of examples out there. But there have been people that have written DSLs, have written proxies, serialization using source generators, IOC that statically resolves everything with IOC at compile time. The Blazor routes one I thought was really interesting. That was written by Andrew Locke. And the idea that he had was in a Blazor app, if I'm specifying a component that you can basically route to that component with a specified path, Blazor code gets compiled into C#, and then that actually gets compiled into .NET. Okay. So at some point, you're going to have a C# class that has a route attribute on it. And so what he did is wrote a source generator to say, I want to find all the classes that have a route attribute on it, more or less. And then look at that route attribute and figure out what's possible to be sent through that route. And then you can almost have like a Swagger type of open API view on your Blazor app to say, here are all the possible routes that you could call. Maybe you use that for like testing purposes and give somebody a way to just invoke things in your Blazor app that will then just route to a new component in a new view in that application. Okay, so that one stuck out to me as a really innovative way of using source generators. Yeah, so that's all I've got in my presentation. If you have any questions, feel free to come off of mute or throw them into the chat. I'd be happy to answer them. And that's all I've got. So thank you for having me tonight.
Yeah,
Thank you very much.
yeah, thanks. Are you packaging these always through like a NuGet package, or do you do it through project references? How generally are you using them?
Yeah, I didn't want to go there. Well, but it
question.
is good that you're bringing this up. I kind of showed you all the wow, amazing. Look at this stuff that you can do. The reality is with source generators right now is the tooling behind it is a little suspect. Um, the C# team has actually admitted that the two features that came out of C#9 that they've been very surprised in terms of their popularity is one is function pointers, which I'm like, really? That one out of all the features, even records, no, that's actually been used a lot more than they expected. But also source generators. They said they knew that people wanted to use that, but they did not expect how much people are using source generators. And the reason I say that is because the tooling behind it does not make it easy. For example, if okay, I can do that. Was okay. I just did a wrong keystroke on something, but I'm fine over here. Okay, so where do I want to go and show this? I want to go back over to here to inline mapping. So if you look, for example, on this test project, which is just unit tests, I reference that project is just a simple project reference, no difference. Okay. But the thing to keep in mind here is that it won't run the source generator stuff as source generators. All it is referencing that project as like a normal class library reference would be. So I can create a new instance of the generator or the receiver and run tests against it. Then that all works, but I don't actually get the generator to generate source code on its own. If I look at this integration test project, notice that I'm using output item type as analyzer. Now, in this case, what's going to happen is you see here, for example, if I go like to map two tests, now I actually get the generator to run. Okay. The problem with this is that if you recompile stuff because you had to make changes, once Visual Studio grabs that reference in this way, it doesn't let go of it. So if you make changes to your source generator, you have to shut Visual Studio down and start it up again. That sucks. I'm just going to say it. That sucks. It's not a nice way to do it. Okay. But at least it's a way to do it. So what I've just gotten used to is building the code in the source generator, writing unit tests directly against the generator and related classes, and seeing if the outputs are correct. Then using integration tests to actually see it work live. And then I also have a NuGet host project here. I'm referencing my local component. This is actually not a reference through the NuGet.org. This is actually referring to a package within my bin release folder. In fact, I have a NuGet config here, and I reference it that way. So that way I can just test, is it working correctly with the NuGet package? Okay. That's also a little bit, you have to watch with version numbers, and if you get an update, did it actually update in this project or not? So long and short is you're probably going to reference this stuff as packages. Like what I did is I made a package and then I'm referencing that from another project as a NuGet package. You don't technically have to do that, as you saw with the integration test project, but it also is not the nicest thing in the world. Now, there's a couple things here that I wanted to show. There are some changes that are coming with source generators. This thing called Granular Source Generator API. This is more about performance and how the generators are run within the IDE. If you go to the .NET Roslyn, the repository there in GitHub, there's a flag out there or a label, new feature source generators. So if you're really interested in this stuff, you can see what people are requesting or what's being worked on. One thing to notice in 1610 for Visual Studio 2019, if I look for source generator, you see debugger support for source generator. So they now have a way here, and I haven't tried this yet, but they're trying to make this better to say if you're building a Roslyn component, to make it a lot easier to debug these components. So again, I haven't given this a whirl, but that seems to work. There's also new support that if I'm in the source generated code and I F12 on something, right now that doesn't work, but they fixed that so that it will work in the future. So you can F12 in the source generated code, and then we'll go to references just like you would expect any other C# code. Okay, so the point is there's more work being done on these things. They know they need to refine and enhance the experience. So if you do dive into this, keep in mind it might feel a little rough at times, but that's just kind of where we are right now. So
Thanks, Jason.
Yep.
So, like you said, and I also believe this is still a new tech. So it'll take some time to mature and bring more features. Mm-hmm. But would you be able to compare, or maybe just share your thoughts, shed some light, if we have to compare the source generator with AOP or maybe IL writing, something like that?
So AOP, aspect-oriented programming.
Yeah.
That's, just so everybody's on the same page. That's a way where you have this idea of an aspect, and the canonical example is a logger. I want to, when I enter a method, log the values that have been passed to me, and then when I exit, I want to tell people that I've exited, and if I know what the return value is, I'm going to log what the return value is. And so this aspect gets weaved into your code at all the right points to do that for you. Source generators are not going to do that because you need the ability to modify the code that exists, and you just can't do that with source generators. So, so again, that's one limitation of source generators. Comparing it to like either IL generation or IL weaving, there's never been any good support in C# or .NET to use tools like Fody or other things like that, in the sense of what got weaved into my assembly. Well, I wrote this code, and now if I use these tools, it weaves in all this other code. And now if I'm trying to figure out what am I debugging or what actually got in there and what order did one of these come before the other one, if you listen to the C# team and some of their interviews, that's kind of why they didn't want this to happen as one, as being a way to edit your code, and two, to have any kind of dependencies from one source generator to another. You may have noticed you can't say this one runs before another, and that's explicit because these shouldn't have any dependencies on another source generator, because of the whole case of, well, now how do you know that this, this one says I should be before this, but this one says I should be before this? Well, then does it matter if one of these is before the other, or stuff like that? So that's another thing that they haven't put in, and probably won't, as far as I know, though that might change. The thing that's, again, so nice about this approach is it's C# code. I can debug it, I can view it, I can see what's going on. And stuff that I've done with IL generation, there's just no easy way to reconcile that and reason about what got weaved in and modified into your assembly. So, and for the most, for pretty much anything that you can do in C#, you can do something that, is it going to be anything? Could you do something related like the object mapping thing I showed? Would there be any advantage to doing that as IL generation? Maybe, possibly. I'm not going to say that there wouldn't be a faster way, but with what I generate in my inline mapping tool, that's about as fast as I can possibly think of. And I don't know of a faster way to do that kind of mapping in IL. So it's just easier to do that. It's far easier for me to think about generating C# code than it is to generate IL. So It's also safer. I know that if I miss one opcode in IL, I'm going to come up with some exceptions that very, very few people, execution engine exceptions, stuff like that, that people just don't ever typically run into. So.
Thanks.
Mhm.